Good afternoon, everyone. Can you hear me? Please inform me through
Yes,
chat
sir.
box
We can
or.
hear you.
Okay. Thank you.
Yes, sir.
Thank you, sir. Thank you.
Yes, sir.
So today my topic parametric tests. So before starting the parametric test, we will start to estimating the assumptions of parametric test. So first of all, we will cover assumptions of the parametric tests. Then second is correcting data. If assumptions of a parametric test do not fulfill, then we use some method to correcting our data like log transformation, square root transformation, and inverse transformations. Once my data is okay after correcting the data, then we can apply parametric test. In case my data, the assumptions of parametric tests do not fulfill, then we use non-parametric test, and non-parametric test equivalent to the parametric test. But I will confine only parametric test. So first of all, we will check the assumptions of the parametric tests. Basically, there are two types of tests. One is parametric test, and second is the non-parametric test. The parametric test basically assumptions based test. And एक मिनट थोड़ा सा एक मिनट के लिए जरा मैं थोड़ा स्टॉप करूंगा अभी एक मुझे epic pen. Yes. So I am writing something. Please inform me whether you are able to see or not. I am just signing. Is it visible?
Yes, sir.
Yes,
It's
sir.
visible.
Okay. Thank you. बस मैं पेन का यूज करूंगा. I will use pen tab. So the assumptions, basically there are four assumptions of parametric test. Before applying any parametric test, we should check the assumptions. So these are the assumptions of parametric tests. The first assumption of the parametric test: data should be normally distributed. Second is the data should be homogeneous. And the third assumption, data should be either ordinal and continuous. And fourth is independent score. So basically, these are the main four assumptions of parametric test. So we can prepare our questions either ordinal and continuous. It is in our hand. And independent score means the score of one person should not be copied to the other person. Means independently, every respondent fill the answer of the questions. So both the assumptions in our hand, but whether data would be normally distributed or not, or the data homogeneous or not, it is not our hand. So we will check the normality of the data through various tests like KS test and Shapiro test. So there are many tests to check the normality of the data, whether data normal or not. So first of all, we will understand the data. What is data?
Sir, your voice is very slow, not properly audible.
अच्छा, हो सकता है मैडम वो जो नेटवर्क इशू हो थोड़ा. ओके ओके।
हम लोग को अच्छा ही आ रहा है सर,
क्या सर?
हम लोग को अच्छा ही आ रहा है।
आप समझ पा रहे हैं सर मेरी आवाज?
हाँ, आवाज क्लियर आ रहा है, उन्हीं का कुछ प्रॉब्लम होगा सर।
मैडम हो सकता है कुछ नेटवर्क इशू हो आपके एंड से।
हाँ हाँ,
Voice is fairly clear, sir.
ओके ओके, थैंक यू सर, थैंक यू। So the whether the data normally distributed or not, we can check it through various methods. And same as whether data homogeneous or not, we have a live-in test to check the homogeneity of the data, whether my data homogeneous or not. So first of all, we will understand the data. So basically there are four types of data, or we can prepare our questions. You are aware, the first is nominal scale, second type of data ordinal, and third interval scale, and fourth ratio scale. So the interval and ratio scale, it is known as metric data or continuous data. And the nominal and ordinal, it is the categorical data or non-metric data. So before applying any statistical tool or technique, we should know whether my data or variable, so there are the data may be metric and data may be non-metric. If I'm saying non-metric, it means I'm talking about the data nominal or ordinal, and metric means the data interval or ratio type. I think you are aware the all the four types of data: nominal, ordinal, interval, and ratio. So the normality of the data, we can check normality of the data. There are three methods. The first method, through graphical display. Just see or look the graph, we can say data normal or not normal. So there are three types of graph. One is histogram, second PP plot, third QQ plot. Histogram, basically the distribution of data should be look like this, normally distributed. Means bell shape. Bell means ganti. Bell shape. Data should be bell shape. If distribution of data look like this, we can say the data is normally distributed. Normal data. Second is PP plot. PP means probability plot. Probability plot. If the distribution of the data lie on this principal diagonal or parallel to this, then we can say the data the normally distributed. And QQ plot means quantile plot. It is same as the probability plot. If data distribution of data on the principal diagonal, then we can say data normally distributed. So through graph, we can check whether my data normally distributed or not. Second method, distribution, skewness and kurtosis. When we talk about the descriptive statistics, it means there are three things. One is central tendency, Second, measures of dispersion. And third is distribution. Central tendency means mean, median, mode. Measures of dispersion means range, interquartile range, variance, standard deviation, mean deviation. And distribution means skewness and kurtosis. Skewness and kurtosis. So the value of the skewness and kurtosis, it should be -1 to +1. If data between the line -1 to +1, it means data normal. If value of skewness and kurtosis outside the range -1 to +1 means -3.28 or +8.2. So data not normal. Not normal because the value of skewness and kurtosis outside the range of -1 to +1. And third method, that is the third method, normality test, KS and Shapiro test. KS means Kolmogorov-Smirnov test and Shapiro test. If p value after applying the KS test or Shapiro test, if p value greater than 0.05, this data normal. Greater than 0.05 means it should be non-significant. For checking the significant difference, we desire p value should be less than 0.05. When we check the hypothesis, p value should be less than 0.05. But in case of assumptions, p value should be greater than. Only assumptions purpose, we desire p value should be greater than 0.05. Same as the homogeneity of variance. Homogeneity of variance we can check through the Levin test. If p value greater than 0.05 means non-significant. If p value greater than 0.05, it means data homogeneous. So first of all, we will understand the concept of normality and homogeneity of variance. So what is the normality and homogeneity of the variance? So assessing the normality. Now, once you obtain the responses from the respondent and you have data in a raw form and you want to apply the parametric test. So first of all, we need to assess the normality of the data, whether my data normally distributed or not. So graphical display. So there are two methods. One is histogram and second is PP, probability plot or QQ plot. QQ means quantile plot. Histogram, when we collect data from the respondent and we check whether data normally distributed or not. So we obtain the graph. of histogram. Now there may be three possibilities. The one is the graph. This is y-axis and x frequency. For example, my question is, I like new education policy 2020. It is a simple statement and you can agree with this statement or you may disagree with this statement. So you can agree or disagree with this statement. One means strongly agree, two means agree, neutral, strongly disagree, neutral, agree, and strongly agree. It's a 5-point Likert scale. And I have many questions. So I need to check each question's normality. If maximum people, so there may be three possibilities. Y-axis means frequency. So the one possibility that my data, the distribution of my data look like this. So if shape of this distribution in a bell shape, then I will say my data normally distributed. But it is not necessarily always my data are normally distributed. Because sometimes what happens, the respondent tick either 1, 2, 1, 2. They may strongly disagree or disagree. So if maximum people give response 1 or 2, 1 or 2, for example, the sample size is 100 and y-axis means frequency. The frequency is 10, 20, 30, 40. And here x-axis options 1, 2, 3, 4, 5. If maximum people are ticking or giving the option, they're ticking the option 1 or 2, 1 or 2, it means if 35 people are taking the option 1 and the second option 40, it means 75 people tick options either 1 or 2 and rest of the people will tick option either 3, 4, 5, means 25 people. So the distribution of data would be look like this. So it's a skewed data, and this skewness known as positive skewness. This data is positive skewness. And the other situation may be this is my x-axis and y-axis, and y means frequency 10, 20, 30, 40. And these are the options 1, 2, 3, 4, and 5. If maximum people are agree with this statement and they are giving options either 4, 5, 4, 5. So the maximum frequency in higher side. So the distribution of the data would be look like this. Again, it is skewed data, not desirable for it is negative skewness. This data not normal. This graph not normal, not desirable for parametric test. This data again it is not normal, not desirable for parametric test. We desire only normally distributed data for parametric test. If this data not normal, means either positively skewed or negatively skewed, then we correct our data. For correcting the data, we have three methods. log transformation, square root transformation, and inverse root transformation. Now, this is about the histogram. And now the PP plot. PP plot, I told you the distribution of the data lie on this line. If the maximum observations lie in this line, then we can say data normal. If distribution of the data in a curve shape look like this, above or below, then data not normal. So the PP or QQ plot, same types plot. Now we check the normality of the data through histogram. Now in this slide, you can see three types of pictures. One is where the data is normally distributed. You can see here the bell shape. The rest of the two shape positively skewed. The distribution of data in a normal shape you can see here in this graph. When I superimpose the normal curve, so this normal curve more or less in a bell shape. So this data desirable for parametric test. Second picture, concentration of the data in a lower side. Maximum people given option in lower side. So the distribution of the data look like this. So this is positively skewed. We should keep in mind, if concentration of data in lower side, left hand side, it means positive skewness. Concentration of data in a higher side, if distribution of data look like this, so this is negative skewed. Okay. So again, the data positively skewed, data not normal, data positively skewed, data not normal. Yes. Now the second is PP plot. When we estimate the normality of the data, we obtain the PP plot, probability plot. If data lie on this principal diagonal, you can see the distribution data more or less on this principal diagonal. So the data is normally distributed. Second is, if data deviate above and below the principal diagonal, and here you can see some observations above and some observations below the this line. So the distribution not in a straight line, it is in a curve shape. So the data is in a curve shape. So this data not desirable, data not normal. Same as the other data, you can see here the distribution of data not in a straight line, it is in a curve shape. So the data not normal, data in a curve shape, again it is not desirable for parametric test. The third picture, QQ plot. Here, very few cases in a lower tail, outside or below the principal diagonal, and very few cases outside. But most of the data you can see lie on this principal diagonal. So we can say this data normally distributed in a quantile plot. Now you see the second picture. the data is completely in a curve shape. This data not normal, not desirable for parametric test. And third is this. Again, this data in a curve shape, not in a straight line. Data not desirable. So this is the concept of normality. Now we understand the concept of okay. After this, we will understand the homogeneity of the variance. But the normality through a graph, we can check normality through histogram, PP plot, or QQ plot. Second method I told you, the checking the normality, that is value of skewness and kurtosis. Skewness means data may be positive skew or negative skew. Kurtosis means the distribution of data. You can see here. Kurtosis tell us about the flatness of the data. If sample size is less, or the distribution of the data not in a bell shape, you can see this data. This is not normally distributed. This type of curve known as platykurtic. If we increase the sample size or the distribution of data look like this, this is mesokurtic. If we increase the sample size, naturally the shape would be look like this, and it is known as leptokurtic. So kurtosis, basically three types of kurtosis. Kurtosis tell us about the flatness of the data. So mesokurtic type desirable for our research paper or thesis. Now platykurtic and leptokurtic not desirable for us. So how do we know whether my data is skewed, skewness, or the whether my data normal distributed or not? If we obtain the value of skewness and as well as the value of kurtosis, both the value should be between -1 to +1. The range, this is the range, -1 to +1. This is minus, this data normal. Ideally, the value of skewness and kurtosis should be 0, but it is not possible. If the data outside the +1 and outside the -1, the data not normal. Data not normal. Okay. Third is the value of skewness. The case test value should be greater than 0.05. The p value should be greater than 0.05, means non-significant. After applying the case test, p value should be greater than 0.05. So this is about the normality of the data. Now I come to the देखिए, अगर कोई क्वेरी हो तो बीच में आप यू कैन आस्क. इफ यू एनी क्वेरी यू कैन आस्क. Okay. Now we understand the concept of homogeneity of variance. So the data should be homogeneous. The second condition of the parametric test. Now, what is homogeneity? The concept of homogeneity we can understand through the two pictures. The first picture I'm drawing here. the y-axis and x-axis. I'm taking 15 families data, the income, monthly income of the 15 families, and expenditure, monthly expenditure of 15 families. I divided 15 families into 3 categories. 5 families I took whose monthly income 50,000. 5 families, the 5 families whose monthly income 1 lakh, and 5 families I took whose monthly income 1,50,000. Okay. Now the expenditure. The mean expenditure of 5 families 30,000. 30,000. One family expenditure 35,000. Another family expenditure 32,000, 30,000, 28,000, and 25,000. So these are 5 families, and the distribution of data look like this. The 35,000 and 25,000, and what is the range? Range maximum minus minimum means 10,000. 10,000 range. Range means maximum expenditure of particular family and minimum expenditure of particular family. The difference between the maximum and minimum, 10th. I took 5 families whose monthly income 1 lakh rupees. They are 70,000. The expenditure, monthly expenditure, 70,000. One family expenditure 75,000, 72,000, 72,000, 68,000, and 65. So maximum 75,000, minimum 65,000, and this is the range. And what is the range? Range 10,000. Same as I am taking 5 families whose monthly income 1,50,000, and the expenditure, mean expenditure of the 5 families whose monthly income 1,50,000, 1 lakh rupees. 1 lakh. One family income expenditure 1,05,000, 1,02,000, 1,98,000, and this 95. So maximum 1,05,000, minimum this, and the distribution of data look like this. So here again the range is 10,000. Now my intent to discuss about the homogeneity. The range should be constant across the group. Range should be constant. So what is the range? 10,000. What is the range? 10,000. It means the variability of the data in a particular category should be same the other category. The variability of the data. If range constant across the group, we can say data is homogeneous. Homogeneous means homogeneity basically tell us about the variability of the data. Now, same case study I am discussing the heterogeneity. 5 families 50,000, 5 families 1,00,000, 5 families 1,50,000. 30,000 monthly, 70,000 monthly expenditure. X-axis income, family monthly income. Y-axis family monthly expenditure, and here the 1 lakh. Okay. If the one family expenditure 35, 32 and range, the range is 10,000. If the one family expenditure is the 1 lakh rupees and the other family's income, the expenditure is 50,000. So this is the range. Here, what is the range here? Range is 50,000. And range here, range 10,000 in a first category. And the third family is the 1,50,000. One family's expenditure is 1,40,000. And other is the 40,000. So range here, what is the range? Range is 1 lakh, 1 lakh. Range is 1 lakh. And the distribution of data is. So here in the second case, range not constant across the group. Here range is 10,000. In the second category, range 50,000. In the third category, range is 1 lakh. So this data heterogeneous data. Heterogeneous. So this is the difference between the homogeneous and the heterogeneous data. So through Levin test, we can check the homogeneity of the data. In this, you can see the graph to understand the homogeneity and heterogeneity. Here, 7 categories: 1, 2, 3, 4, 5, 6, 7. In each category, the range more or less same across the category. But here, the range is very less in a first category, and range in the last category, it is very high. So the data is heterogeneous. But we can check heterogeneous when we check it through the software, SPSS software. We apply the Levin test, and the value of the Levin test p value greater than 0.05. In case after applying the normality and homogeneity, if my data not normal, not homogeneous, then what should we do? We correct our data. So there are 3 methods to correcting the data. The first method for correcting the data, the log transformation. Log transformation reduce positive skewness. Second method is square root transformation. Third method, reciprocal transformation. So these are the 3 methods to correcting our data. Still my data not normal, not homogeneous. Then we will go for non-parametric tests. Basically, non-parametric tests are assumptions-free tests. We do not need to check the normality and homogeneity in a non-parametric test. You can see the 3 pictures. The first picture in this slide, the before log transformation data is skewed, positive skewness. But after correcting the data, it is more or less normally distributed, but not exactly in a bell shape. Second method, when we correct our data through the square root transformation, you can see before the square root transformation, data positively skewed, okay, which is not desirable. After correcting the data, applying the log transformation, the data shape you can see more or less in a bell shape. The data is normally distributed. Now the third is inverse reciprocal transformation. In a reciprocal transformation, this is the third method to transform or correcting our data. Now here, before correcting data positively skewed, and after correcting it is more or less normally distributed. This is about the assumptions of the parametric test. Now I will take 5 tests, 1 sample t-test, independent t-test, paired test, analysis of variance and repeated measures, ANOVA. But before it, I will check normality and homogeneity of the data through SPSS software and how to correct our data in a software. We will do it. Now you can see the data set, but before it, yes, ठीक है. Data set है, I think you can see this data set. In this case study, the biologist wants to know the hygiene condition of the accommodation. In this case study, 800 participants participated in a seminar, and 800 participants stayed in a guest house. So they stayed in 3 days, day 1, day 2, day 3. And the biologist collected data from the 800 participants regarding the hygiene condition of the accommodation. And the biologist given the questionnaire 0 to 4 regarding the hygiene condition. 0 means poor hygiene condition of the accommodation. 4 means excellent. And now you can give your opinion between 0 and 1. Means you can give your opinion 0.78. You can give your opinion 2.34. That is why you can see in this data set, the first respondent given the day 1, he given his response 3.23. Means accommodation condition is, the hygiene condition was good day 1. And day 2, the hygiene condition of the guest house, some not up to the mark, and day 3 it is bad condition. So these are the score of 800 participants. Score you can see. This data set you can see. Okay, this is data set. Now I am checking the normality and homogeneity of the data. So how to check it, the normality? For normality, you can go for analyze, descriptive statistics, and explore. Analyze, I'm checking normality of the data. Analyze, descriptive statistics, explore. I'm transferring all the 3 days data, hygiene condition of day 1, day 2, and day 3, and transfer all the 3 variables into the dependent list, and then plots. I need only your normality, so I'm taking this normality plots with test. So I will use only case test for checking the normality of the data, whether my data normally distributed or not. So here you just press this button, continue, and after continue, okay, and now you can see the output. This is output, but in my data set you can see some missing score also. In day 1 there are some missing score. In day 2 missing score, but in day 1 all 800 participants were present in a guest house, but day 2 some are not present, some were not present in day 2 and day 3. If we have missing data, then how to check the normality? So go to analyze, descriptive statistics, explore, and transfer all the 3 here, but we need to click the options also. If my data absolutely right means there is no missing value, then there is no problem, directly we can go for plots, tick this normality. But if we have some missing cases in day 2 and day 3, then we need to tick the one option, that is exclude case pairwise. Otherwise what will happen, it will calculate only one only non-missing data. Okay, and then continue, and then okay. Now you can see the I'm showing both the graph. Here you can see the day 1 800 participants were present. In day 2 262 were present, and day 3 only 122 present. If I don't tick this option, I'm showing you again the option. Yes, you can see here and analyze, descriptive, and explore. If I don't tick this option, then it will give the output only the valid cases. I'm showing you. Earlier I did not tick that option. So yes, earlier I did not tick that option. That is why here only 122 cases were valid, non-missing data. Okay, but so we should check whether is it any missing value in the data set. If missing value is there, then you go for options. If there is no missing value, then directly you can perform. So now you can see the data set. Day 1 800 present, day 2 262, and day 3 122. First of all, we check the normality. The normality you can see here, the day 1, day 2, and day 3. In day 1, the value of KS test, Kolmogorov Simronov, the value is P value, how much? 0.193, which is greater than 0.05. So this data normal. 0.05 means 5%. And here you can see this data is 19.3%. ठीक है ना, here 5%. So data should be greater than 5%. So here data is 19.3%. So data normally distributed. In day 2, data not normally distributed because p value less than 0.05. This data not normal. And day 3, again p value less than 0.05. So this data not normal. This data not normal. Only day 1 data normal. Now question is, if my data not normal, how to correct this data? So this is about the normality. Now I check the homogeneity of the data also. Homogeneity, go for analyze, descriptive statistics, explore, then reset. I am resetting all the 3 questions. Again, I am transferring all the 3 questions into the dependent list. For homogeneity, we require at least 2 categories, and gender has 2 categories, male and female. That is why I am transferring this categorical variable into factor list. Now again, I am opening the plots. I need normality plots and leave-in test for untransformed, leave-in test for homogeneity. So I ticked normality plots with test, and homogeneity I take this untransformed. It will give us value of leave-in test. And then continue. After continue, okay. Now you can see the picture. The this is, sorry, non-missing. Missing. एक minute. Analyze, descriptive statistics, explore. Okay, transfer all the 3 variable in dependent list and categorical variable into factor list, and options, because day 2 and day 3 missing values. Again, I am ticking this option, exclude cases pairwise, and continue. After continue, okay. Now it is good. The day 1 305 male and 495 female. Day 2 102 male present and 160 female present. Day 3 male 55 and 67 days. I come to normality. I am checking the normality. This is the result of normality. The result in this table, there are 6 values. Day 1 normality of male it is good. P value greater than 0.05. Day 2, it is less than, day 1 less than for female. Day 2, normality for male, no normal. For female, not normal. Yes. Day 3, again, male data normal because P value greater than 0.05. And this not normal. For checking the homogeneity, we take the first row value, that is 0.030. So this data again not homogeneous because P value less than 0.05. So if we obtain this type of data, then we should correct our data, or we can use, or we can apply non-parametric test if my data not normal, not homogeneous. Now this is about the normality and homogeneity. Now the how to correct our data. I told you there are three types of correcting method: log transformation, square root transformation, and reciprocal inverse. So first of all, I am taking log transformation. Transform, compute variable. I'm creating the new variable, the log 2. Log 2 means day 2. I'm correcting this data. Same whatever name I have written in a target variable, I'll copy and paste in type and label and paste here, and then continue. So press this button, all, and select log 10, and transfer in a numeric expression box.
Sir,
Hello, yes, madam.
sir, can you please repeat log transformation once more?
Bilkul, yes.
Okay, thank you.
So first of all, go to transform, compute variable, then write the name of the variable. I am writing log 2. It is researcher choice to write the name of the variable. I written here log 2 means log transformation, and 2 means day 2. And then you can give any name, and then copy same name, you copy and paste in type and label, and you paste it and then continue. Then we need to select the log 10. So here function group, you can see all. We just press this button, all, and in the below dialog box you can see the functions and special variables. You can select log 10, this log 10. After selecting log 10, you just press this arrow button, and then log 10 will appear in this numeric box. So I have pressed this button and it appeared in a numeric expression box. So here you can transfer the log 2 hygiene condition. So ये log 2, because my options of this question were 0 to 4. If in my option there is no 0, means my options are 1 to 5. You tick option 1 to 5, then I don't need to correct it. But I have given options 0 to 4, so that is why I am adding the +1 value. In case if any observation has 0 value, then log 0 means infinite. That is why I added here +1. If your options in a 1 to 5, then there is no need to add the +1. Why did I add this +1 value? Because in my options, 0 number was included. That is why I, and then you press this button, OK. So this is the first method. And the second method, this is log2. Second is square root transformation. Go to transform, compute variable, and reset. I'm writing here SQRT2, square root transformation. Copy, type and label, and paste, and then continue. After continue, press this button all and select SQRT, square root, yes, SQRT, and press this button arrow. Now again you need to transfer this variable d2. Here we do not need to add any value because square root of 0, again it is 0. So, and then okay, this is the second method of log transformation. Third is inverse root transformation. How do we do it? Transform.
Sir, please once again show the SQRT2.
G. This is SQRT, madam.
Square root.
हाँ, square root transformation है ना ये. Square root transformation. ठीक है मैडम.
Okay, sir.
Third method of transforming, that is inverse or reciprocal. Go to transform, compute variable, and then write here reset all. Write here INS. I am writing here INS2. Inverse. INS2. Copy. Type and label. Paste in a label, same thing. And continue. And then directly you can write 1 upon inverse. What is log 2? Here I am again, sorry, day 2. Again I am adding +1. Why? Because if any respondent value 0, the day 2 value 0, 1 by 0 means infinite. That is why I have added the +1. And then OK. Now I have 3 transformation. Now I can apply these 3 variables value in a histogram. I'm creating histogram through this. Graphs, chart builder. Okay. Histogram. This is histogram. Double click. Log 2 histogram. Log %. Display normal curve. Now you can see the graph. Earlier, the graph, I'm showing you the graph of the before transformation of day 2. So before transformation, the graph is look like this, and after the transformation, you can see it is more or less normal distributed. Second graph of square root. Go to graphs, chart builder. second is square root, and then okay. So in this graph, you can see this is more or less normally distributed. Okay. And third method, that is inverse root transformation. The graph of inverse transformation. Again, you can see here the graph is, you can see the graph. More or less normal distributed. Not exactly, but more or less. So this is about the assumptions and correcting the data. So I take 5 minutes break, and then I will discuss one sample t-test, independent t-test, analysis of variance, repeated measures, ANOVA.
Okay.
Okay, 5 minutes break. Sir,
Yes, sir. Please.
Okay. Okay, sir. Okay.
thank you. Hello.
Yes, sir.
Okay. Thank you. Now I will take 5 tests, one sample t-test, independent, paired, ANOVA, and repeated measures, ANOVA. So one by one, first of all, I'm taking one sample t-test. Now you can see the case study of this test. The case study is relating to the weight of the students. ABC University indicates that the mean weight obtained by students in a class 53 kg. This is my population, and the population mean equal to 53 kg. University is saying the mean weight of this class 53 kg. A teacher from the same university claimed that it was more than 53 kg. It means the weight of the students more than the 53 kg. Who is claiming? The teacher. Teacher is saying the mean weight of the students more than 53 kg. And then administration can say, prove it. Then teacher collected the 10 students data. He found the first student weight is 50 kg, 55 kg, 54, and so on. So this is our sample mean. Okay. So here we want to generalize population on the basis of this sample. Sample means a small part of the population. And teacher collected data of 10 students. And the population was 100 students. So first of all, we will develop the hypothesis. Hypothesis nothing but it is simple statement. It is simple statement. And statement may be right or wrong. Here the teacher statement is the mean weight of the students more than the population mean. Okay. So here in a null hypothesis we always assume there is no significant difference between the population mean and sample mean. It means the population mean equal to the sample mean. After applying the parametric test for one sample, if p value in a null hypothesis, p value would be greater than 0.05. It means after applying the one sample t test, if we get p value more than 0.05, it means there is no significant difference. Null hypothesis, alternate hypothesis always opposite to the null hypothesis. It means there is a significant difference. P value does not, population mean value does not equal to the sample mean value. If p value less than 0.05, it means there is a significant difference. The teacher claim correct. Now, how to perform it through the software? This is one sample, the case study of one sample t-test. 10 students, weight of the 10 students. Because data is continuous, we will check the normality of this data. We don't need to check the homogeneity because for homogeneity we need at least two groups. So it is a one, we are analyzing only one variable. So we will check only normality. Go to analyze, descriptive statistics, explore, and then weight of the students in a dependent list and plots. Normality plots with tests.
Sir,
And then one. Hello.
Yeah, if you make it slow, that we can put it in the notebook.
Yes, sir.
Yes, sir. Yes, sir. If you slow down the process, the analyze, and then the descriptive, and then yeah, we are noting the steps.
Should I repeat it?
Yes, sir.
Okay, no problem. For to analyze, it is same as earlier. Descriptive statistics explore. I am estimating normality of the data. Analyze, descriptive statistics explore.
Yes, sir.
Weight of the student transfer into dependent list. Then press this button, plots. Select normality plots with test. Then continue. After continue, OK. And here the p-value. So what is the p-value here? Greater than 0.05. It means data normally distributed. P-value greater than 0.05. Now we can apply the non-parametric test. This is non-parametric test. One analyze, compare means one sample t-test. Analyze, compare means one sample t-test. Weight of the student transfer into test variable, and the test value was 53. Population mean was 53. We should keep in mind when we compare two means, whether it is sample mean or a population, always the difference, always there would be some difference in a population mean and sample mean. Whether the difference significant or not, p-value tell us. If p-value less than, it means there is a significant difference. So we transfer weight of the student in test variable, and the test value was the population mean 53. And then press this button, OK. Okay, now you can see the output. In this output, this is our sample mean. Population mean was 53 kg, and the teacher took 10 students, and the sample mean 56.9 this. So there is a difference of 3.9 kg. Whether this difference significant or not, who will tell us? This p value, and here p value 0.191. P value greater than 0.05. It is 19.1%, 5%. It means there is no significant difference. No significant difference. This difference is by chance. It is not very much difference. If 53 kg population mean and sample mean 70 kg, then there would be a significant difference, but it is very little difference. So this difference is not significant. Now question is how to report the result of this test. From the output, since p value greater than 0.05, we do not reject the null hypothesis that sample mean is equal to population mean and conclude that sample mean of students is not significantly different from the population mean, it means teacher claim was wrong. Now the second case study of independent t-test. Independent t-test, we compare two mean. In independent t-test, basically, what is independent t-test? If we want to compare the two means, then we apply the independent t-test. In independent t-test, we have two variable, one dependent variable y, another independent variable. The condition of a dependent variable, the data should be metric, and condition for independent variable, data should be non-metric. It means if we want to compare the two categories like male or female and dependent variable salary, if I say the female teachers are getting lower salary in private institutions, it is my hypothesis. So how will I prove it? I will take salary of male teachers in a private institutions, salary of female teachers in a private institutions, and then I will take the mean and compare. Then I will check whether this difference is significant or not. So in this case study, the example to know whether the salary of male faculty members in private institutions is equal to the salary of female faculty members. So researcher collected data from 20 male and 20 female faculty members in private institutions to know the difference. This is my case study. So first of all, I will name the hypothesis. In the hypothesis, there are two types of hypothesis, null and alternate. The first hypothesis, there is no significant difference between getting salary by male and female teachers in a private institutions. गवर्नमेंट में तो सेम है सबकी सैलरी, बट प्राइवेट इंस्टीट्यूशंस में कोई जेंडर डिस्क्रिमिनेशन है या नहीं, वो हम चेक करना चाह रहे हैं. And the alternate hypothesis, there is significant difference between getting salary by male and female teachers. This is my case study. Now I check whether the difference is significant or not. The researcher took 20 male teacher salary and 20 female teacher salary. First of all, we will check the assumptions of this parametric test, non-independent t-test. This is my data set. Go to analyze. Analyze, descriptive statistics, explore. And then, what is your gender transfer into factor list? Salary of teachers transfer into dependent list. Now press this button, plots, and select KS test and live-in test. Select normality plots with test and for homogeneity untransformed. And then continue. After continue, OK. Now you can see the p-value of Normality plots. What is the p-value? Greater than 0.05, 0.20, greater than 0.05, greater than 0.05. So data normal and homogeneous. There is no issue of normality and homogeneity. Directly we can test our hypothesis through independent t-test. This is my data set. I am applying independent t-test. Analyze, compare means independent sample t-test. Analyze, compare means independent sample t-test. What is your gender transfer into grouping variable? And there are two coding, one for male, two for female, and continue. Salary of teacher transfer into test variable, and then okay. Now you can see the output. In this output, there are two means the salary of teachers, female teachers and male teachers, Y and X. The mean salary of male teachers $49,900 and mean salary of female teachers 39,400. So how much difference? 10,500. Whether this difference significant or not, who will tell us? P value. This P value. And what is the P value? P value less than 0.05. It means this difference is very much difference, very significant difference. It is not a small difference. Now we can conclude that we can generalize in a private sector there is a gender discrimination. Now question is how to write the results. From the output, T value was 4.068. That the number of degree of freedom on which this was 38, and that it was significant at P value less than 0.05. The mean value for each group on average, male teacher obtained higher salary to female teachers, and this difference was significant. So we will report our result in this manner. The third case study, pair t-test. We apply pair t-test when we want to compare same respondent. We observe same respondent two times, before and after. Before and after. In this case study, ABC University arranged a special faculty development program for one segment of its teachers. The university wants to measure the change in the attitude of its teachers after the faculty development program. University wants to change the attitude of teachers university wants to motivate their teacher to do positive work. For this purpose, it has used a well-designed questionnaire which consists of 10 questions in a 5-point Likert scale, and university selected 20 teachers. So now they measured the uh, attitude score of 20 teachers. The first is before training, the score was 25, and after the training program, the score is 38. Sorry. Before training, the score is 35, and after training, 45. Third is participant 24, 42. Fourth participant 16 to 32. It means there is, we can see some difference is there. Now we want to know whether this difference because of faculty development program or not. So we want to know the impact of this faculty development program to enhance the attitude of the teachers. So I am taking the case study. Yes. So before the faculty development program, the score of 20 teachers, you can see. And after the faculty development program, the score of 20 teachers. So we will check the normality of this data. For normality, we will not check the individual variables, but we will check normality of the difference of this data before and after. So I created the third table, that is difference. I will check normality of this variable. Analyze, descriptive statistics, explore, difference transfer into dependent, and plots, normality plots with tests, and continue. And then okay. Yes. So p-value greater than 0.05, there is no significant difference. Matlab, no significant difference. P-value if greater than, and it is desirable for normality or assumptions. So data is normal, no problem. Now I check the impact of training program on teachers' attitude. Analyze, compare means, and paired sample t-test. Paired sample t-test. Transfer before and after, and then okay. After okay, yes. You can see the mean score before FDP 24.75, and after FDP the score is 33.25. There is a difference, but whether this difference is significant or not, who will tell us? P-value. Last three columns you can see here, the p-value. What is the p-value? P-value less than 0.05. 0.05. It means there is a significant difference. It means the faculty development program motivate a student to do some work, or they change the attitude of the teachers. Now, how to report the results? So first of all, we will develop the hypothesis, and after that, we will report the results. This is the reporting of the result. The t value was minus 7.94. The number of degree of freedom on which this was 19. and it was significant because p value less than 0.05. And here we have given before faculty development program the mean score and after faculty development program, and this difference is significant. Now we can say it changed the attitude of teachers. The fourth case study of analysis of variance. In this case study, 15 shops, retail outlets, and in this case study, we want to know the impact of sales promotion or impact of discount on sales. Discount on sales. So in this case study, there are three situations. We are no promotion, and here the mean sales, here medium promotion and high promotion. So we want to know whether the promotion increase the sales significantly or not. So analysis of variance we use when independent variable more than two categories. In independent t-test only, the limitation of independent t-test, we can compare only two categories. But if we want to compare more than two labels, two categories, then we use ANOVA. So here there is three categories: no promotion, medium promotion, and high promotion. So here we are comparing the three categories. First of all, we will develop the hypothesis. The mean null hypothesis, the mean outcome is same across all categories. There is no significant difference. The mean is same more or less in all the three categories. But alternate hypothesis, at least one pair of mean different from mentioned. ANOVA. So you can check assumption formed in one sample, independent and paired. I'm directly performing one sample. Oh, sorry, ANOVA. Analyze, compare means, and one way ANOVA. Analyze, compare means, one way ANOVA. Sales, categorical variable, sales promotion, transfer into factor. Sales in lakhs, transfer into dependent list. And press this button, contrast, nothing to do. Post hoc, choose Bonferroni, total 18 test. Post hoc test tell us about the difference in pairs. And then options, descriptive, homogeneity, means plot, continue. And then okay. Yes. Now you can see there are three labels. When you do not do any promotion, you don't give any discount, the mean sale of the 5 retail outlets, 22 lakhs. When you give the 10% discount, the sale increase, mean sale. And when you give the 30% discount, the sale also increase. So there is a difference. From the data, we can say there is a difference. But whether the difference significant or not, who will tell us? P value. If P value less than 0.05, you can see here the P value from the ANOVA table. From the ANOVA table, the P value less than 0.05. It means there is a significant difference. This difference is significant. 22 and 32, 22 and 50. But we do not know whether the sale outcome due to medium promotion or high promotion. So we will check it through the post hoc analysis. We will take the pair of this and pair of no promotion with this. So we will get two pairs and check the yes. So here no promotion and medium promotion. There is a difference of 10 lakhs, but whether this difference is significant or not, this p value tell us, and here p value 0.845. This difference is not significant. When we compare no promotion with high promotion, then what is the p value? The difference is 28 lakhs. Yes, this difference is significant. So we can say high promotion, due to high promotion, we can increase the sales of the product. And the last case study, that is the repeated measures ANOVA. Repeated measures ANOVA, we apply repeated measures ANOVA when we take observations more than 2 times for same respondent. In this case study, the dietitian introduced new diet chart plan to reduce weight loss. The dietitian took 15 women who considered themselves to be in need of losing weight and put them on this diet for 3 months. Their weight was measured in kilogram at the start of the diet and after 1 month, 2 months, and 3 months. So repeatedly we are measuring the same respondent more than 2 times. That is why we are using repeated measures. We want to know whether this diet plan reduce the weight of the participant or not. Initially, the weight of the first participant is 105 kg, and after the first month, 98 kg, 92, and 75. So the date is the weight of the participant. You can see, you can compare the weight of the participant decreasing after 3 months. Okay. I'm performing the repeated measures ANOVA, analyze general linear model and repeated measures. Analyze general linear model and repeated measures. Right here, weight. How many level? 4. Add. Define. Select all the 4. Transfer into within subject variables. Model. Nothing to do here. Contrast. Repeated. Select repeated. Change. Continue. After continue, plots. कुछ नहीं करना, nothing. Post hoc, nothing to do. Options. Transfer overall and weight. Compare main effect, select SIDAC. Tick descriptive estimate, transformation, and then continue. After continue, okay. Yes, you can see the weight of the participants, the mean weight, baseline mean weight 102. After 1 month, 93. After 2 months, 85. After 3 months, 69. So weight, the mean weight significantly decreasing. Whether this difference is significant or not, we can check through this test. Pillai trace, Wilk lambda, Outling trace, and Roy largest test, all the p values are less than 0.05. So it means this training program reduce the weight of the participants. So this is about the parametric test. और मैं सर को शेयर कर दूंगा जो पीपीटी है, हम लोग जो पीपीटी यूज कर रहे हैं वो पीपीटी में सर को यूज और डेटा सेट भी शेयर कर दूंगा. और अब अगर कोई आपका क्वेरी है तो यू आर मोस्ट वेलकम टू आस्क द क्वेरी.
एक्सप्लेन काय स्क्वायर टेस्ट